Okay, here we go. Um, the first thing you need to know is what a mutual fund is. A mutual fund is an investment where you put your money in with another group of people, and together the company who owns the mutual fund decides what to do with the money. So what companies they invest in. Usually mutual funds are super safe and really consistent, and you can almost always count on getting a bunch of money out of a mutual fund. So a super safe investment. Um, the return rate is 3% on this mutual fund, which is a great rate. And we see that it's compounded quarterly. Okay, so quarterly is 4 times per year, just like there are $4 and a quarter, 4 quarters and a dollar. So N is 4. Your R is your percentage rate, so R is 0.03. Remember to turn it into a decimal. Your P is your principal. P is 100. So the first thing we need to do is we actually need to write an equation for this model, for this problem. And we're going to use this one because we see this key word here, compounded, and then it says quarterly. So if you see compounded quarterly, then you got to use that formula. If it says compounded monthly, N would be 12. If you see compounded 45 times per year, then N is 45 times per year. Okay, so A equals P is 100 times 1 plus R is 0.03 over 4. What that does, by the way, is it splits the formula, it splits the rate into 4 pieces. So that kind of makes sense. We're only getting a quarter of the rate at each time. Okay, times 4t. T is our variable, and that's the thing that we're going to be changing. Okay, so the question says, how much is this investment going to be worth after 1 year, 5 years, 10 years, and 45 years? So that's what we're putting in for T, kind of like we did in the Nearpod. I encourage you to use Desmos or your TI-84 calculator for this. That just makes it easy because then you can just change what T is at each step. So I'm just going to write the answers and then I'll give them to you. Okay, so here are our answers then. The next one is about a credit card. And so this is sort of a different type of problem, but a very similar process. Here's what it says. You spend $150 on some new clothes. Um, and you pay with a credit card. This is a very common thing that people do. They pay with a credit card and then they pay it off the next month. But here's the situation about what happens if you don't pay it off. You spend $150. Our P is going to be 150. Credit card has an annual rate of 24.95%. This is a very common rate. That it happens a lot that the rates are super high on credit cards. So R equals 0.2495. And you could probably predict what's going to happen here, that this is going to grow so much faster because the rate is so much higher. Okay. And then it says compounded monthly. And so we have our N equals 12 here because there are 12 months in a year. Our equation is going to be A equals, okay, well, 150 times 1 plus our rate is 0.2495, 0.2495 over 12 to the 12t. Most credit cards do compound monthly. Okay, so plus they have late fees, so that's even worse. Okay, so now you can put in these values for year. 1 year is 1, and then a year and a half would be 1.5 years. So you can see how quickly those two, that interest rate bumps up how much money you owe on that credit card. Okay, the next one is just an annual rate. It says compounded annually, and so that would be 1 time per year, which is the same as this formula up here. So we can use A equals P times 1 plus R to the T. This also makes sense because N would be 1 here, and so then you can see how the N's don't change the formula at all, and that's why that first formula works. Okay, so A equals, our principal is 250 times 1 plus 0.05, that's what 5% interest is, to the t. Okay, so put those t values, 2, 4, 6, and 12, into your formula and see what you get out. And there are your answers for that one. Okay, this one, we're going to use the word continuous as an indication that we need to use A equals PE to the RT. Okay, our rate is 10%, so R equals 0.10. That's 10% as a decimal. And then P is our starting value, which is 10, so P equals 10. So write an equation for the model. Well, we have A equals 10, and then we use the letter E to the 0.10. We can just write 0.1 times T. Notice that the rate is per minute, not per year. And so that means that each of our T's are going to be minutes. So then, if we need to figure out how many cells there will be after 10 minutes, then we're going to put in 10 for T here. One note about using Desmos on this problem, when you do the 10e to the 0.1 times t, it's important to put that exponent in parentheses, or else it will keep the exponent from having a multiplication symbol in it. It really doesn't like having those, so you have to put the parentheses there to make sure that works. Your answer for this one would be 27.18 cells. Okay, after 1 hour, well, 1 hour is 60 minutes. So you can put in 60 for T. Just be careful because you have to make sure that your units make sense with the problem. Okay, so then if I get that, my answer is 4,034.29 cells. Okay, can you have a partial cell? Talk to your biology teacher, I'm not really sure. Okay, the last one is one that we really haven't talked a lot about yet this lesson, but it is sort of the same process as the last one. The word that we see here is decay and continuously. And so this is an indication, because it has the word continuously, you have to use A equals PE to the RT. But decay means shrink, get smaller, decrease the amount. Instead of grow. We've seen every example so far has been a growth example. This one is a decay example. Rate is often, when it's with a decay problem, it's often written as a decimal already. Notice that there's no percent symbol here. So R equals negative 0.7. Notice that this would mean that R is negative 70%. So if we're really thinking about what this means, it means we're losing 70% of the element. And it says every year this happens. So every year we lose 70% of the amount of element we have. Okay, so let's think a little bit about what this means. So our P is 1,000. So that's no problem. A equals 1,000 e to the negative 0.7 t. Remember that t is in years. So that means that this is, okay, so this is years. So how many years is 6 months? Well, 6 months, because that's what the first question is asking. 6 months is 0.5 years. 8 months is 8 out of 12 years. By the way, that's 2/3. 12 months is 1 year. 24 months is 2 years. So that's why I'm telling you, be careful about what the problem is saying, because this problem says every year we are given our rate. So if we're given a yearly rate, we have to turn all of our times into years. So now I think you can put in these values, 0.5, 2/3, 1 year, 2 years, in for t right here. See what you get out, and I'll put my answers down in a second. And there are my answers. Notice that I have them in grams so that my units are consistent. So there's just kind of a lot to pay attention to here. But there it is.